Today's explainer. Right now, all around us, there are these invisible but absolutely incredibly powerful threads connecting literally every living thing on our planet. Think of our environment like this perfectly calibrated, wildly complex engine. Every single part, whether it's totally microscopic or absolutely massive, has a very specific job to do. But what happens when something messes with that delicate balance? What happens when a giant wrench gets thrown straight into the gears? Well, that's exactly what we're going to explore today. Okay, let's just dive right in with a seemingly simple question. How in the world does energy from a massive star, millions of miles away, yeah, our sun, somehow end up fueling the sprint of a leopard out on the savannah? I mean, it sounds like pure magic, right? But it's actually the incredible, perfectly structured mechanics of nature's food chains and energy transfer. To figure out this mystery, here's our roadmap for today. First, we'll look inside the ecosystem. Then, we'll map out food chains and webs. Third, we'll track the flow of energy. And finally, we'll tackle human environmental impact. All right, part one, inside the ecosystem. So at its very core, an ecosystem is really just a community of living and non-living things interacting together. Basically, our world divides neatly into two foundational buckets, biotic and abiotic. On one side, we've got the biotic components, that's all the living organisms, from the tiniest bacteria all the way up to huge mammals. And on the flip side, we have the abiotic components. These are the non-living physical factors, things like temperature, rainfall, wind, and soil. And here's the kicker. You literally can't have an ecosystem without both. The living things rely absolutely, entirely on the parameters set by the non-living things. Moving right along to section 2, food chains and webs. Now, to survive, these living creatures interact through three main roles. First up, you have the producers. These are the absolute foundation, actually creating their own food through photosynthesis. Then you've got the consumers. This group includes your herbivores, carnivores, omnivores, and even parasites, and they depend, either directly or indirectly, entirely on those producers just to survive. And finally, we can't forget the unsung heroes, the decomposers. We're talking bacteria and fungi here. They basically clean up the whole operation, breaking everything down and recycling those crucial nutrients right back into the system. Let's take a deer, for example. A deer is a primary consumer. As a classic herbivore, it feeds directly on green plants, our producers. So the deer acts as an essential link, stepping that energy right up from the plant world and bringing it straight into the animal world. And this naturally builds into a direct, linear sequence. Secondary and tertiary consumers, think of a fish or that leopard we mentioned earlier, they create what we call a food chain. The fish eats smaller primary consumers, while the leopard sits way up there at a higher trophic level. These connections are direct, they're ruthless, and they are completely necessary. Which brings us to section 3, the flow of energy. Here is where the real mathematical precision of the ecosystem shines. Energy flow is strictly a one-way street. It goes from the sun to the plants and then up to the consumers. But get ready for this, because this is a truly mind-bending fact. Out of all the roaring sunlight hitting the Earth, green plants manage to capture just 1% of that solar energy. Just 1%. That incredibly tiny fraction is literally the spark plug for almost the entire web of life on our planet. So from that tiny 1%, energy starts moving up the chain. But there's a massive catch, something known as the 10% law. As energy transfers from, say, a plant to a deer and then from that deer to a leopard, only 10% of the energy actually makes it to the next level. Think of the other 90% as this incredibly heavy biological tax. It just gets lost as heat, or it's burned up by the organism just trying to, stay alive and go about its day. And because of this massive 90% energy tax at every single stage, there simply isn't enough fuel left in the tank to sustain long food chains. This is exactly why food chains generally max out at only 3 or 4 steps. By the time you finally reach a quaternary consumer, that initial energy captured by the plant has been reduced to a microscopic fraction. Nature's engine runs on incredibly tight margins, for sure. All right, on to our final piece, section 4, human environmental impact. A really stark example of where things go wrong is biomagnification. Remember how we just said energy decreases as you move up the food chain? Well, certain chemical toxins do the exact opposite. Biomagnification is the increasing concentration of these harmful chemicals in organisms at successively higher trophic levels. Because these toxins aren't broken down or lost as heat like energy is, they just accumulate. So the top predators, our tertiary consumers, end up with the highest, most dangerous concentrations of these pollutants right in their bodies. Another absolutely critical impact is happening high above us. Let's break down the invisible chemistry of how our atmospheric shield naturally forms. Step 1. UV radiation splits a standard oxygen molecule into two free oxygen atoms. Step 2. Those highly reactive free atoms combine with other regular O2 molecules. And step 3. Ozone, or O3, is formed. This acts as a vital planet-wide shield, actively absorbing the sun's most harmful UV rays. But here's the wrench in the gears. Human activity introduced pollutants, most notably chlorofluorocarbons, or CFCs. These were widely used as refrigerants and in fire extinguishers for years. The problem? These CFCs actively cause the thinning of that protective ozone layer. And the result of that thinning is increased UV radiation hitting the Earth's surface, which leads to some pretty stark health consequences. We're talking higher rates of skin cancers, eye cataracts, and even immune deficiency disorders. Now, recognizing this massive threat, there was actually a huge global preventive shift, making it totally mandatory for manufacturing companies worldwide to produce CFC-free refrigerators. Finally, let's look down at the ground and see what we're leaving behind because it heavily disrupts those natural decomposers we talked about earlier. Biodegradable waste, like leftover food or paper, is safely broken down by natural bacteria over a relatively short period of time. Non-biodegradable waste, however, things like plastics and metals, simply cannot be processed by natural decomposers. Because of this, they persist in the environment for a really, really long time, acting as incredibly harmful long-term pollutants. So, what does this all mean? From that tiny 1% of sunlight captured by plants, to that brutal 90% energy transfer tax, to the invisible chemical shields floating high up in our atmosphere, our environment is a perfectly calibrated, interconnected engine. Everything relies on everything else. But with toxins biomagnifying in our predators and non-biodegradable waste permanently piling up on the ground, we really have to ask ourselves, if we keep throwing wrenches into these delicate gears, when the engine finally breaks, where exactly does that leave us? Thanks so much for joining me for this explainer today. I'll catch you next time.